Many people know about these tanks which are filled with sand. During summer months, unnecessary solar energy heats the sand up to 600 degrees Celsius, and this thermal energy will heat houses in the winter. Perhaps some people do not believe that the temperature can be stored for several months, and they think that the hot sand will cool down quickly, but nevertheless it exists in reality, and this is another real example in Serbia. Here solar radiation heats air to 800 degrees Celsius, and the hot air heats stone blocks inside the tank during summer months to use this thermal energy to heat houses during the winter months. The Finns revealed their secret, saying that thermal energy from the hot sand is taken through this pipe, which leads to a radical decrease in the temperature of the sand at the periphery of the tank, and therefore these heat losses are reduced several times. The secret of this Serbian tank is not revealed, but I think they take the thermal energy by passing air through gaps between the stones here on the periphery with low thermal conductivity, and therefore the temperature of the periphery decreases several times. Those two methods work well in cases of large volumes of the hot mass for heating a large number of houses, like this tank from that Finnish company. But unfortunately, those two methods do not work well in the case of a small tank just for heating a single house. But this video will describe the third method, which ensures that a small tank of summer solar heat will work well for winter heating of a single house. Our third secret method will be described on the following example of heating a house in the Netherlands from this my old video. That project used this traditional Indian mirror dish which focuses solar radiation into this cast iron well, and therefore several tons of the cast iron are heated above 400 degrees Celsius. The hot cast iron constantly heats the 78 tons of sand and stones up to 400 degrees Celsius in October, and this thermal energy will heat the house in winter. These heat losses were stopped by this thick thermal insulation, this soil, and the phenomenon of a slight decrease in the temperature here on the periphery, and here I show the kilowatt-hours of the heat losses, and they reach this maximum in September and October. This project did not use our secret methods, and therefore the total construction cost of the entire system reaches this level in the case of heating a house in the Netherlands. But the following 5 steps will radically reduce this cost, and therefore our system of using free solar radiation can be better than traditional heating systems based on natural gas or heat pumps. We remember that the Finns placed the pipes here, but our method proposes to place the pipes here inside this thermal insulation, whose thickness was 1 meter in that Dutch project. But now here we form an empty gap 5 cm thick, and the hot air of this gap will heat the air inside such cheap pipes with a maximum temperature of 250 degrees Celsius. Similar pipes are assembled into this structure, which is located in that gap. This is the circulation of the air, which takes the thermal energy from that gap and goes through this heat exchanger, where the air heats this water of the home heating system. The homeowner changes the heating power of the house by changing this flow of the air, and the temperature in the gap outside these pipes is like this during the 5 months of the heating season. This is the power of the heat transfer from those pipes to the house, but its heating requires this power, and that is why we see this lack of the power in the home heating system. This lack is covered by this old method of circulating air through the cavity of the cast iron well, and the homeowner controls the power by changing this flow or this air flow. These are the heat losses from the tank, and we can compare them with these heat losses without our secret method, and we see that our method reduced the heat losses by almost 3 times in these winter months and by almost 2 times in these months. This is a comparison of the cost of this old situation without our secret method and this new situation. We see that the reduction of the heat losses has allowed us to reduce the volumes and areas of these parts of the tank and these other elements of the solar heating system. That is why our secret method reduced this construction cost by $3,300. We only get the opportunity to reduce these heat losses when we take a lot of thermal energy for home heating from November to April, when our method intercepts these heat flows, directing them to the home heating system. In other words, a minute ago I already said that now the temperature here is like this for different months, while the absence of our secret method previously led to such temperatures, which are 2 or 3 times higher. In addition, the reduction of heat losses allows to reduce the volume of the tank or its temperature, and these solutions additionally reduce the heat losses, including in the summer months. I have already said that the temperature around this gap has such values in different months, and the temperature affects these heat losses from the tank, which are reduced to this level due to the reduction of the temperature to this level due to the following. Firstly, this airflow was increased by 2 times, the capacity of this heat exchanger was increased by almost 2 times, and the number of these pipes was almost 2 times more. Secondly, replacing these heating radiators with underfloor heating reduced the temperature of the heating water by about 10 degrees. Thirdly, the reduction in heat losses allowed us to reduce the maximum temperature of the tank from 400 degrees to 388 degrees, which further reduced these heat losses. It is interesting that the following solutions will reduce this gap temperature even further. We can abandon these pipes so that the air from that gap can circulate here, but perhaps we should install a filter here. We can also come to the decision to replace this gap with a layer of this well-known product, and this air circulation is replaced by water circulation. Perhaps this heat exchanger will not be needed so that this water of the home heating system circulates through these pipes. Unfortunately, these polymers can sometimes be exposed to temperatures as high as 250 degrees Celsius. That is why we have to look for other solutions, for example, similar pipes which are used for solar collectors and can withstand about 200 degrees, and it would be better to increase the width of the fins almost 10 times. But we can install here a layer of aluminum sheets with a thickness of about half a millimeter, and these pipes with narrow fins will be pressed against the sheets and will be installed at a distance of 80 centimeters from each other. Let me remind you that this part of the thermal insulation of that Dutch project was aerated concrete, and now I will describe one of the examples of how to make those pipes in this large mass of aerated blocks. For example, here we can lay a layer of slabs made of dense concrete with maximum thermal conductivity, and the slabs form 7 such channels for the circulation of air, which will take this heat to reduce these heat losses. Let's use these channels not for heating the house, but for its hot water supply, both in winter and in summer. The temperature of these concrete walls of the channels is like this. This temperature allows us to constantly heat water in a tank with such power, which creates these kilowatt-hours of heat for hot water supply. These are the heat losses through the aerated concrete mass, and we can compare them with these heat losses for the case when we did not have those channels for the heat extraction. We see that the heat extraction for hot water supply has reduced the heat losses by approximately 2 times, but I remind you that these heat losses are less than half of all the heat losses from our tank. It is obvious that the more effective example would be to fill the channels with sand and gravel and install pipes here for the constant circulation of water from a tank for several hundred liters of hot water. Here we see a low temperature which causes this decrease in power and heat production, and if this seems to be a problem, we can use the following solution. Here we form the second layer of concrete channels, which will work instead of this first layer in this way during those 5 problematic months, and here we see good temperature of the walls of the concrete channels. We can make different parts of the tank cheaper or reduce the area of this mirror dish, and these cost reductions will be described in my future videos. Our solar heating system has the right to cost $10,000 or $20,000 more than traditional heating systems because it produces a lot of free solar energy. Firstly, these 3,000 kilowatt-hours of free solar energy for hot water supply saves the homeowner almost $1,000 annually instead of expensive electricity for Dutch households. Secondly, the system provides about 10,000 kilowatt-hours of free thermal energy for heating the house, saving another $1,000 annually compared to natural gas or heat pumps. In addition, we can install a greenhouse or conservatory, which will be heated by these heat losses from the tank. We can also add this gap of several tens of centimeters in width, so that these heat losses are converted into heating of this air which heats the greenhouse. In addition, cheap summer solar energy can heat water in a swimming pool, which is important for the cold summers of the Netherlands or Scandinavian countries. Moreover, the heat extraction from the tank for the pool radically reduces the heat losses from the tank, and let's assume that we heat a pool from May to October, when we will take heat through another gap which is located here. The maximum temperatures around this gap will always be less than 150 degrees Celsius, and therefore we can use cheaper pipes than for this gap with a maximum of 250 degrees. The temperature around this new gap during the pool season is like this, and this temperature allows us to constantly heat the pool water with this power. This is the heat losses from the new gap to the outside, so that we can compare them with these previous cases of heat losses from the tank. We see that the heat extraction for the pool reduces the heat losses by more than 2 times for this month and by almost 3 times for this month. It is interesting that we can use the new gap to heat the house in November, which leads to this November heat losses, which are almost 1.5 times less than I showed in this previous case 5 minutes ago, or in this case 8 minutes ago.